We're continuing with the College Algebra Final Exam Review. We're on page 6 of the review document that deals with the transformation of functions. And the first question says, determine the transformations performed on the graph of f of x required to create the graph of the function g of x equals f of x minus 9 minus 11. So if you'll remember, when we looked at this earlier, some of you had a difficult time with this, and there's basically 4 variables. You have an a, and then you can have f of bx minus h plus k. And so there's 4 variables, 4 parameters there that can affect or transform the function. And I'm going to review those real quickly. A, if you'll remember, tells us whether or not it's going to be a reflection on the x-axis, and that's determined by the fact that it's negative. And it also tells us if there is a vertical stretch or compression. B tells us whether there's going to be a reflection or a flip on y, and again, that's determined if it's negative. And B is if there's a horizontal stretch or compression. H tells us the horizontal shift, whether you're going to go left or right. And then finally, K tells us whether or not there's going to be a vertical shift, which would be up or down. So if I look at the expression that we're given, f of x minus 9, I notice that I have basically the h and a k. Since the k is negative, I know that means I'm going to move down 11 units. And then remember to be careful because the formula has this minus in there, so you have to do the opposite of the h. So our h is minus 9, so the opposite of minus would be positive, so we would go right 9 units, and that would be the transformations that have taken place. The second question, you're actually given a graph, and they tell you that the graph on the left is the graph of f of x. So this is f of x. And the one on the right is g of x. And they want to know, what did you do? How did you move the graph? How did you transform the graph to go from f to g? And so honestly, the way you figure this out is by looking at some of the key points. So for example, if I look at the origin point, which is one of the x-intercepts on the original graph, and I go over here and I try to find that same point has moved up 2 units and left 1 because it's no longer at the origin, it's gone up 2 and left 1. It may be easier to see that if we look at the low point of the graph, which on the original graph occurs at 1, negative 2. So if we start at 1, negative 2 to get to where that point is located now, again, we have to go up 2 and left 1. So it appears that for the transformation that's taken place is we're going up 2 units and left 1 unit. Now to express that in terms of an equation, the up 2, remember we're going to add 2 to the function, and to do left 1, we would add 1 to the x value. So it would look like f of x plus 1 plus 2. And guys, honestly, that's the best way to do it, is just to kind of follow those points and see how they're transformed. The supplemental question is very similar to that. Again, you have the graph on the left, which is f of x, and you have the graph on the right, which is g of x, and it wants to know, again, how did you get from f to g? And this time, I'm going to start with one of the main points of a parabola or a quadratic is the vertex or the low point. And originally, it's at -1, -2. So if I start at -1, -2 on the graph on the G graph, then to get to where the vertex is on the other graph, I have to move 1, 2, 3 units to the right, and 1 unit down. So I went 3 to the right and 1 down. Now I want to confirm that using another point. So maybe I use the point 1, 2. So if I start at 1, positive 2, and I move 1, 2, 3 to the right, and 1 down, I've located a point. So it appears here again on this graph that we're going 3 right and 1 down. Well, to go down, we have to subtract 1. To go right, we have to subtract the 3 from the x. The next group of questions ask you to decide whether given functions are one-to-one. And guys, the easiest way to do this is going to be to use your calculator and put the equations into your calculator and create the graph and use the horizontal line test. So if I'm doing the first one on my calculator, I would press y equals. I'm going to clear out what's in there, and I would type in 3x squared minus 2x plus 4. And I'm going to have it graph. Now, you may recognize that before you even graph it. Hopefully you realize that this is a quadratic, and a quadratic is a parabola shape. Okay, so we know this is going to be some kind of U shape, and if it's a U shape, whether it's turned up or down, it's not going to pass the horizontal line test. So a quadratic is never one-to-one. So we would have to say, no, this function is not one-to-one, which means there's no inverse. For the second one, we have -2. Again, I'm going to put it into my calculator. So I'm going back to my calculator. Y equals, clear out the one that was in there, and then I'm going to put in -2 parentheses x plus 11, close the parentheses, raise it to the third power, and add 9. And I'm going to tell it to graph. And I don't really see all of the pictures, so I'm going to tell it to zoom out so that I can see and get a better idea of what this graph is doing. It kind of looks like this crooked line going down the screen. Again, running the horizontal line test for this one, I can say yes, that it does have that it is one-to-one, and the fact that it is one-to-one tells me that it will have an inverse. Then you have the supplemental questions, and again, it's the same idea, guys. You want to just create the graph unless you kind of know what the equation is going to look like before you graph it. With letter A here, 3x minus 7, you might recognize that as a line, and pretty much any line is going to be one-to-one with the exception of a horizontal line. So letter A here, we would say yes, it is one-to-one. Then if I move on to letter B, we have the square root of 5x plus 9. Again, if you're familiar with your basic graphs, you know that pretty much any square root is also going to be 1-to-1. So again, we would say yes. With letter C, again, I have a quadratic, so I know it's going to be a parabola or that U shape. And so, as I mentioned earlier, a parabola or a quadratic is never 1-to-1. Question D, or letter D, we have y equals, let's clear out what's in there, parentheses 4x minus 7, close them, raised to the third, add 8, and graph. And again, you kind of get this zigzaggedy curve, which does pass the vertical line test, or excuse me, horizontal line test. And so we would again say yes, that particular function is 1-to-1. Now, the last one is absolute value, and you may or may not be familiar with what the absolute value equation looks like. And to find the function on your calculator, you press the button that says Math, arrow to the right to highlight num, ABS, option 1 stands for absolute value, so we type in ABS, 2x plus 7 minus 1, and we graph. With absolute value is always going to be a V shape, and because it has a V shape, it does not pass the horizontal line test, and therefore would not have an inverse. So remember, if a function is not 1-to-1, it does not have an inverse. To decide whether it's 1-to-1, you create the graph and run the horizontal line test.